The dramatic history of the brain, a story never told before. Let us travel back in time to the mid-15th century and meet a 14-year-old girl, future to be Queen of France, Catherine. Catherine is forced by her family, the Medici of Florence, to marry the unpromising Prince of France, Leroy Henry II. 10 years later, she has 2 kids with the prince. Henry II was never groomed for the throne, as he had an older brother who took over the kingdom. Unfortunately, his brother dies after a game of tennis, and Leroy is next to the throne. Now meet Diane de Poitiers. Fancy name, huh? Well, you may wonder who she is. She is the cousin of Catherine. Diane marries a man 40 years older than her, right about the same time as Catherine's marriage. Yeah, I know, that was a thing back then. Well, surprise, surprise, Diane's husband dies before her. Diane, with her beauty at age 35, wastes no time and turns cougar and starts hitting on her cousin's husband, Henry. She first enslaves him with sex, then holds the sex over him as a political power until she finally marries him. Henry, not experienced in the throne, starts a series of stupefying complex wars with Spain over Italian territories, bankrupting the realm. By the late 1550s, Henry owes $43 million in loans to creditors, over twice his yearly income, with some loans at 16% interest. Finally, Henry signs a treaty with Spain. However, there are 2 important clauses in the treaty that establishes alliances through marriage: an immediate wedding for Henry and Catherine's 14-year-old daughter to the King of Spain. Well, there goes again. And a second for Henry's sister to marry an Italian duke. To celebrate the marriage, Henry organizes a 5-day jousting tournament. And we're finally caught up. Today is the 3rd day of the tournament. Henry decides, hey, I'm feeling good today. I want to compete as well. After 2 consecutive winning rounds, Henry decides to compete against a young Scotsman named Gabriel Montgomery, one of the best at jousting. Although Catherine and many others, including the famous astrologer Nostradamus, warns against Henry's risk of taking part in this competition, Henry refuses and ignores everyone. They are faced forward, they ride towards each other, they clash, and Henry gets hit. Montgomery strikes him just below the neck, and Henry loses his balance and nearly falls off his horse. Now embarrassed, with lots of ego, and Henry decides, well, tell it again. They go at it again, and this time, Henry falls off his horse, as the shrapnel of Montgomery's joust punctures into the gold-plated visor of the king and pierces into his eye. That's the last ray of the light the king sees. This is the story of brain's significance. The rotational forces become a more deadly injury than the initial eye puncture, since torque stresses the brain unequally at different points, tearing at its soft seams and opening up thousands of microhemorrhages. Henry had suffered a concussion. Many surgeons, known as barber surgeons because they learned by cutting things, attended Henry to find ways to help him. Meet the first surgeon, Ambroise Paré, who was a royal surgeon. He refused to go with traditional knowledge. The second surgeon was Andreas Veisalis, who also learned through gladiator dissection of human bodies that many of the old traditions about human anatomy were incorrect. Both surgeons, after multiple hypotheses, predicted the king would die. King Henry II of France finally succumbs to an intracranial hemorrhage at 1 p.m. on July 10th and dies from his injury. As we know today, inflammation and fluid pressure can crush brain cells, destroying the switches and circuits that run the body and mind. This explains why injuries can be lethal even if the skull suffers no fracture. The injury Henry suffered was known as a counter-coup injury. And now we shall continue to learn about the history of the brain's significant discoveries as we move further on.
Now we will look at how an assassin, 2 rival researchers, and several frog hearts changed our understanding of neurons for the better. First, we start with Charles Gusteau. Yes, the man who assassinated President Garfield, a Republican president, in the name of the Republican Party. Yeah, we don't have enough time to unpack all that, so we're going to quickly go over the history of Gusteau's life to discover what led him to this point. In his early years, he joined a sex cult, then left after being freezed out by all the women, started a newspaper that failed, wrote a book about Stanley and Livingston being signs of the apocalypse, and then had to mooch off his sister's family. That is, until he swung an axe at her head and had to move out. Typical family drama, am I right? After a failed marriage and a case of syphilis, he wrote a speech in support of President Grant's third term. Wait, what's that? Garfield got the nomination? He wrote a speech in support of Garfield and read about 2 paragraphs of it in New York before his stage fright got the better of him and he quit. Garfield won the presidency. Well, obviously, this is due to Gusteau's marvelous speech, so it was time to claim his position in government. He would be perfect for a Paris consulship. Gusteau did not, however, receive the position, and worst, Garfield was destroying the Republican Party. "Kill Garfield," said God, obviously. So he shot Garfield in the lower back, and was caught immediately. George Scoville, the brother-in-law, defended Gusteau at trial, pleading insanity. Gusteau refused such a plea, but then also interrupted the trial with verses, songs calling the jurors jackasses, and announcing his candidacy for president. So we can assume, based on his history, that 140 witnesses, including psychologists, concluded, yes, that he was completely and utterly sane. Wait, what's that? Edward Charles Spitzka thinks he's insane? Pray tell, which events led you to your reasoning? The God delusion, the lazy left eye, and the crooked smile. Only those? Well, he found himself to be correct when he performed the autopsy. Although the brain looked normal on a macro level, it was not on the micro. His gray matter was thin or non-existent in places. There were intermediate neuron deaths that made the brain look like carbonated soda and yellow-brown gunk everywhere. The insanity must have been caused by a chemical imbalance. Although at the time, insanity was thought only to be due to brain damage, Spitzka was more correct than he seemed. We now come to our next neuroscience duel. In this corner, we have the reticulists, scientists who believe the brain's neurons act in unison as one big cell. And in the other corner, we have the neuronists, who believe in the existence of individual neurons with gaps in between one another. And fight! Ooh, the reticulists are bringing out Camille Golgi, a well-known scientist of the time. What's this? Oh no! While working, he elbowed a beaker of silver solution onto a slice of owl brain. Wait! How gorgeous! We can see neurons versus glial cells for the first time. Fascinating. Look, everything is so closely entangled, the brain must work as one unit, with all the cells melded together. Ooh, that's a point for the reticulists. Wait, what's that? The neuronists are fighting back and have sent in Santiago Ramon y Cajal, an artist? Ooh, an artist who became a neuroscientist. He is redoing Golgi's experiment and claiming that there are gaps between the cells. The decay of one neuron does not continue to the next. It stops. The cells are made of dendrites, a cell body, and an axon. And with the publication of the neuron doctrine, Cajal scores a point for the neuronists. It's a tie, folks. Both share the Nobel Peace Prize in 1906, and boy, do they not look happy standing near each other. This might not be a Peace Prize after all. Dear listener, the neuronists are the clear winner. Don't be fooled. Thanks to Golgi and Cajal, we knew neurons existed, but we didn't know how they communicated. It's time for our next division, Sparks versus Soups. The Sparks believe that neurons communicate using electricity. Why? Because when you remove a frog heart and place it in a saline solution, it will beat on its own, and you can speed it up if you spark different nerve strands. The Soups believe that neurons communicate using chemical signaling, but there was very little proof until Otto Loewy had a dream about winning the Nobel Prize. He ran to his lab and put 2 frog hearts into separate beakers of salt water. They began to beat. He stimulated one heart with electricity, causing it to beat faster. Then he took some of the saline solution from the fast-beating heart's beaker and squirted it into the other beaker. The heart immediately sped up, and the winner is the Soups. Chemicals called neurotransmitters are the culprit. The history of neuroscience is rife with dueling scientific ideas, and the book does an excellent job examining the culture of the times and how it influenced the science, such that political climate explains the claims of Gusteau's sanity, and the economy of Spain explains the inability for the neuron doctrine to be mass distributed for years. But there are more historic events to go over. To you, Natalie.
They say that once you learn how to ride a bicycle, you never forget. It's a phrase most of us have heard at least once before in our lives, maybe as encouragement when we were learning how to ride one ourselves. It's not just a nonsense saying either. People who haven't ridden a bike in years can hop on one and soon find themselves racing through a Davis roundabout. The question is why? Why can our brains remember skills we haven't used in a decade, but struggle to remember the name of a coworker or a classmate we just met yesterday? The answer lies in the hippocampus, a structure between your ears about the size and shape of a thumb. In the mid-20th century, neuroscientists were able to determine how the brain encodes memory and the role the hippocampus plays in that process through the rather extraordinary case of a man known simply as H.M. H.M. suffered a skull fracture in the early 1930s after being struck by a cyclist. His accident caused him to suffer from epileptic seizures beginning when he was 15, sometimes as many as 10 seizures in a day. The shaking, blacking out, and other associated symptoms were so severe that they eventually led to him dropping out of high school. Eventually, the impact on his life was so drastic that he decided to try surgery with Dr. William Scoville, a neuroscientist with a reputation for being boldly experimental with brain surgeries. In 1953, H.M.'s operation took place. Scoville removed the hippocampus from each side of his brain, along with the amygdala and other nearby structures. Although drastic, the surgery initially seemed to have few side effects. H.M.'s personality was largely the same, and the seizures had vanished. However, it quickly became apparent that his memory was completely shot. He had lost the memories of about 10 years of his life prior to the surgery and could not form new ones. Anything that happened to him vanished the moment it was no longer happening. He could not remember how to get to the bathroom, whether he'd eaten breakfast, or whether he had already asked the question he was asking. When word of the surgery and effects spread, another neuroscientist, a PhD student named Brenda Milner, took interest in the case. She began testing H.M. to see the extent of his memory damage. Initially, she confirmed Scoville's findings that he had little memory of his past and no ability to make new memories. However, when she began testing his motor skills, she found something interesting. There was a particularly tricky test involving drawing a 5-pointed star between two existing ones while looking at the paper in a mirror instead of directly. All patients, even those with all of their brain intact, made a mess of it the first time, as did H.M. But when they continued to repeat the test day after day, his star got neater and neater every time, despite his inability to remember ever doing this before. He had learned how to do it. This was huge. It was the first conclusive evidence that two distinct types of memory existed and that they were processed in different parts of the brain. Until Milner and her star test, neuroscientists believed memory was all the same, regardless of what the memory was. Now we know that memory can be separated into declarative memory, like names and dates, the kind H.M. couldn't do, and procedural memory, like riding a bike or drawing a star, the kind he could. It was a landmark distinction. Milner's tests, however, didn't stop there. When asking H.M. to remember a random number while she went out for a coffee, she found that if he kept repeating the number over and over to himself, he could remember it. But the moment he was distracted or thought of something else, the number was gone. He could do the same with words or short phrases. This showed yet another distinction, that between short and long-term memory. If the number was constantly refreshed, it kept it in his short-term memory, and his short-term memory had remained intact. If it was not constantly repeated and it slipped into the past by more than a moment, it became a long-term memory that he simply could not form. H.M. became a neuroscientific celebrity after these tests, becoming one of the most widely studied brains of all time. His case study is both important and fascinating, as it granted us the first real insight into how the brain classifies and processes memories. Brenda Milner provided proof for distinctions that we now take for granted both in the field and out of it. Short-term and long-term memory are familiar terms to many people with no neuroscience experience, and the difference between procedural and declarative memory has impacted strategies for early childhood development and education in the classroom for decades. This case is also important because despite its popularity, very few people know that Brenda Milner is the mind behind these breakthroughs. In a field that's largely male-dominated, it's important to recognize and give credit to female neuroscience, particularly Brenda Milner's contributions to the field of memory. This case is a snapshot of how neuroscience works. Despite a huge tragedy or an experimental surgery gone awry, the human brain finds some strange new way to continue to live, and we continue to find strange new ways to study it.